Now, with the basic training we did in 2.6, we're now going to do some extension of that in this section, doing graphing techniques, where we're going to be stretching the graph, shrinking the graph, reflecting the graph, dealing with symmetry, and then even and odd functions, and translations. So when we look at something, and I scanned this and read it in some detail, but let's just jump right into what they're saying here. For example 1. Now, when you see something like this, and they're saying the absolute value of x, but you're going to multiply it by 2. What does that do to the graph? Well, if we look at a graph here, our red line is the absolute value of x. So if we double these as we go through our graphing, we're going to get a value of x, then we're going to double it, which is what they show here. We get new points. So what have we done? Well, we have gone from where there was a 1, in a sense, outside here, to a 2, and this has gone up here, up there, and that way. And it is symmetrical to either side of the y-axis. We spoke of that before. And what have you done? Well, we say you have vertically stretched this. You've stretched it up. That is, with a 2 in front of something, it's put this line a little closer to your axis of symmetry. So go from here to here, you've stretched that. Now, how about if we put in 1/2? Well, again, if this is our 1, 1/2 of this is going to be a line like so. Okay, and remember, you can't have any values below 0, so that is as close as you can get there. All right, let's continue. Now, part of what we're doing here in this section is developing vocabulary. So again, this was the 1 absolute value of x. This is 1/2 the absolute value of x, and we sketched that in on the previous image. So this is a vertical shrink. Okay? So let's continue. So here, if we have a particular shape of the line, and our original line was the black line, then what have we done by doing the blue line? Well, this is vertical stretching. And again, if our original line was the black line, what have we done here? We have done some vertical shrinking. And of course, this dialogue over here to the side will support what we've just said. Now, how about if we have that was vertical above. How about now if we have horizontal stretching or horizontal shrinking of the graph of a function? Well, take a look at this. The black line is your original. And what have we done here to the blue line? We've stretched it. So this is an example of horizontal stretching. And this one, again, the black line is the original. What do we notice is happening to the blue line? That is horizontal shrinking. So, just some vocabulary as we build up toward what we'll be doing here in a little while. Okay, we're now going to go to this topic of reflecting. And I did mention that a little bit in a previous lesson, but let's take a look at it. And this is called reflecting the graph across a line. Now, in most cases, this line will be the axis of our graph. So, we're asked to graph this, in which this is a negative value of the square root of x. And we had done these already. We said the square root of x in the previous section, when we graph it, is just this line here. And we said if we put a negative in front of it, we get the reflection down there. And it's reflected across what axis here? Well, this is the x-axis. We might say that our x-axis is our axis of symmetry. That is, what's on this side is a mirror image of what is on the other side. And that's what they're showing here. Now remember, we had said that if you have something like this, this is not a real number. You can't have a negative value underneath this. So that would be, in a sense, undefined. Okay. And here they're showing us that where theoretically you might get a reflection across the y-axis now, these numbers are undefined. And here they're talking about reflecting across an axis. And we've illustrated that a little bit. And we're looking at this topic again, symmetry. What are things that are symmetrical? That is, what is on one side is the mirror image of what's on the other side. Now, as you look at this, the mirror image is symmetrical to what axis? Well, it's the y-axis right here. Right there. Now, when we had the equation, as we had seen earlier, where the parabola is on its side, there is symmetry, but not to the y-axis now. This is symmetrical to the x-axis, as we see here. All right, we want to test for symmetry with respect to an axis now. Well, of course you might graph it. Now, in your quiz bee in practice, you'll be working out examples, so you need a technique to resolve the questions they're asking. And what we do is we replace the x with a negative x, and if it's still true, then it shows that it has symmetry with respect to the y-axis. Now, if you substitute a negative y for where our y is, it does not result in an equivalent equation, and thus the graph is not symmetrical in respect to the y-axis. Now, What is nice about our textbook is that they then show you the example. Now, let's analyze this one just a little bit. Here, our equation, our function is y equals x squared plus 4. And we did say, if you recall, y equals mx plus b. What did we say b was? Well, it was our y-intercept. And in a situation like this, is 4 our y-intercept? And the answer is absolutely. So we see then, by looking at this as a parabola with our vertex at 4, that there is symmetry to the y-axis. Now, here, when we have x equals y squared minus 3, notice the minus 3, since it's x, is going to be on the x-axis, which is sort of the side vertex, and then this opens up this way, and this does not have symmetry to the y-axis, but it has symmetry to the x-axis. Okay, and that's what they're showing, and they're giving work to support that. I think the pictures are very good. Now, here's another equation we did when we worked with circles. We had said that when it's x squared plus y squared, the origin of the circle is our, or the center of the circle is the origin right there. And then we took the square root of this, which gave us 4. So there is our radius from the circle. Now a circle around the origin shows symmetry to both the x-axis and the y-axis. Now in this other equation that you're seeing here, and let's see if we can write an equation for this. Y equals, a little review of previous things. We're going to need a slope here. We have x plus our y-intercept is 2. So what is our slope going to be? Well, this is 2 and this is 4. So how about a negative 2 and over 1? So negative 4 over 2, or a negative 2 over 1, or just plain negative 2. Now, do you see any symmetry here in regard to our x and y axes? And the answer is no, and they have that there. Okay. Now, we can look at something like this, where we talk of another kind of symmetry when a graph can be rotated 180 degrees around the origin, with the results coinciding exactly with the original graph. Now this type of symmetry is called symmetry with regard to the origin, which is your 0, 0. Okay? So, if this is your first function, and this is your second function, notice you've reversed both signs. Does this show symmetry in regard to the origin? And the answer is yes. And here we have this function in blue, and if we rotate it 180 degrees, we get this function. Is that an example of the origin symmetry? And the answer is yes, by this definition up here. Okay? So again, they're showing you this angle, sort of. This is a straight angle which is 180 degrees. That's what this dotted line refers to. Okay. Now, testing for symmetry with respect to the origin. Well, we knew this was the circle above, so that does show symmetry in regard to the origin. Now, for this one is this graph that we had seen earlier. Does this show symmetry in regard to the origin? And it says it is symmetrical with respect to the origin. All right, so keep in mind that if you made this negative and you made that negative, changing the x and y's to negative, and it's still the same pretty much equation, then it shows symmetry to the origin. Now notice if you made a mirror image of this line, it would swing it up there, and that would be also symmetrical to your y-axis. And if you did that, reverse the signs, that would go down as well. Okay. Now I like it as the textbook is going. They're giving us a number of items of review here. So here's a little summary. Graph symmetric to both the x and y is automatically symmetric with respect to the origin. Okay. A graph symmetric with respect to the origin needs not be symmetric in respect to other axes. Figure 80 shows that. Of the three types of symmetry with respect to the x-axis and y-axis, and with respect to the origin, a graph possessing any two types must also exhibit the third type of symmetry. And again, you're not going to master this until you start practicing it. I'm trying to go over the vocabulary and give you a little background for this. But it's your practice and later your mastery that will hone your mastery of this. And then here are a nice little test for symmetry. Equivalent equations if unchanged. Example. All right, so this one shows it above and below. So this is symmetrical to the x-axis. That is by changing the y is replaced with a negative y. And here if x is replaced with a negative x, this is your parabola. And this is in regard to the origin. Rotating it 180, you have symmetry. Wow. In this next one, they go over even and odd functions. And to make a long story short, after going through all of this, they give you a shortcut. Wow. That if your exponents on the variable are even, then this is going to be an even function. If your exponents on the variables are odd, this is going to be an odd function. And then if one is even and one is odd, then it's neither. Wow. And they're going to show you all the algebra of it. And we'll let you go through that if you want. But here is the summary right there. And of course, x to the 0 power is excluded. Okay, we're now going to do what is called translating a graph vertically. and looking at the absolute value that we had earlier, and keeping in mind here that in our slope-intercept form, once again, what did we say this is? This is our y-intercept. So what's going to happen when we have this absolute value and then we have a negative 4? Well, this is without the negative 4. So for this one, our y-intercept is 0, and that's where it's anchored. Well, where will this one be anchored? What's our y-intercept? It's going to be down here at 4, and I've cut it off so you can see this, but we'll raise it up now, and there you see it. So what have we done? We have translated this graph vertically, going from its original y-intercept of 0 to now the y-intercept of negative 4. This should be very useful to you. Now, we talk about vertical translations, and again, our C we can think of as our y-intercept. Okay? So, these are functions in which they're giving you the y-intercept at 2. So this function goes through at 2. Here it's going through at plus 0. Our y-intercept is 0. And here our y-intercept is a negative 3. Now, when I looked at this, I said, how did I get the wavy line out of that? This is just for demonstrating the y-intercept with the vertical translation from 0 up 2 units or vertical translation down 3 units. And again, what we're featuring is this plus 2 out here is your y-intercept. This function of x here is not this wavy line. That's just to show you the translation. Here it's graphed a little bit better and show you what a graph might look like. Okay, let's go on. All right, now, and the thing we want you to keep in mind here, a couple of things. Now this is what we've just done. And we said this was the y-intercept. So this moved your graph down to 1, 2, 3, 4, and then it looked like so. Now how about if the negative 4 is included in the absolute sign, which is what we see here? What does that do to the graph? Well, remember, we solve what's in the absolute sign by saying x minus 4 equals 0. So what would x become? Well, x is going to be a 4. So where is a 4? X is a 4 on this particular graph. Well, here we're translating a graph horizontally when it's in this particular configuration. Here this was a y-intercept, moving it up or down. Within the absolute sign, it's going to translate it horizontally. And notice this is x minus 4. When we solve it, it becomes x equals 4, and that's where we will put our translation horizontally. Okay? And here they're going over the work in this paragraph. So once again, a couple of important things for your notes. If you are shifting this up or down, then the value out here is the y-intercept. If it's negative, it's going to shift it down. If it's positive, it's going to move it up. But within the absolute sign, think of it as the opposite sign of what is there. If it's x minus 4, it's going to shift it to a plus 4 because of what I've shown you there. All right, let's go on. So here's the rule. And again, there's sort of the formula, x minus c, but whatever value is there as a minus c will become a positive value that you're shifting it. Now, if it were plus c, then it would shift it to the left. If it's negative c, again, it becomes plus, you shift it to the right. And again, these lines are just reference lines. So there's an f of this function here, x plus 2. They're shifting it 2 units to a negative 2. Here, this is just that. It's at 0. And here, it's a negative 3. We're shifting it opposite sign to a positive 3. So I love this graph. Here they're showing you the y-intercepts, shifted up or down. Within there, it's opposite signs. Here, this is to the left. This is to the right. Again, pause the tape, look at your textbook, take some notes. Let's go on. Okay, so now we're going to use more than one transformation here. And let's see if we can analyze letter A. Took me a moment to set this up, but here's what we have. We want you to graph this. Well, first of all, try to copy it correctly here. There's a 1 there, not a 2. Better. Okay, so what did we say this was out here? This was our y-intercept, sort of. But that y-intercept is going to be shifted to where? Well, this is positive, so it's going to be shifted to the negative 3 and now up 1. So that's the first point of your graph. And since all of this is negative here, whatever value you get, it's going to look like so. Now, I didn't draw this to scale. Here it is to scale. But again, if you plotted a couple of points, that's what you would have gotten. So what have we done? From the original point of intersection, which would have been a positive 1 here, we shifted that over 3 units. 3 units, that's the tip then of ours, and because it's negative, it's going to be opening downward. Everything becomes negative because of that negative sign there. Now, in example B here, we're looking at this, and they're saying, well, what can we do? We would factor the 2 out of there, and then factor this into 2 parts, so we then get a 2 outside. So again, we're going to shift this because of the negative 2 in here over 2 units. Negative 2 gets shift to the right, and then we're going to make it closer. This is the spread out version. Remember, these come up because of it's 2. And the word I was looking for is stretch. We're stretching this to become this. And if it was 1/2, we would be shrinking it. Just a review of terms we said a little earlier. Okay, let's go on. Now, for this one, as we look at it, Because of the x squared being negative, the parabola is going to open up downwards, and the 4 then is our y-intercept, and therefore our vertex of this parabola. And again, if this were 2 or 3, it would come in closer to the y-axis. If it was 1/4, it would kind of open up wider. Sort of the opposite of what we have here. Okay, lots of stuff going on. Now here they're showing what happens when we are graphing translations of a given graph. So let's say this is f of x, and again, that's just representing this function, and we want to move everything up 3 points. So I don't do this very well, but I'll show you what they mean. So this point goes up 3. 1, 2, 3 goes right there. Now this is going to go up 3. 1, 2, 3 right there. And this point goes up 3. 1, 2, 3. And this goes up 3. 1, 2, 3. And this goes up 3. 1, 2, 3. So as we translate this, it just becomes this now. That has been shifted upward to our new intercept's y-intercept. That this one, our y-intercept, is 0, which is right there. And now with the +3, it's shifted upward. Now, this is a little different. Notice this is within the parentheses. So here we're going to shift this figure to a -3. So this point here, 1, 2, 3, let me clear that one first. This one gets cleared now, and we shift it over to the negative value. This goes there, 1, 2, 3 goes out there, this goes 1, 2, 3 out there, and you get the idea that when it's in the parenthesis, it gets shifted to its opposite sign. And this one, compared to this original, is going to be up 3, but over a +2. Let me show you that one too. So this one, let's use our point right here. This is where it was originally. We're going to shift it up 1, 2, 3, but now we're going to shift this point over 2. And this one is going to be shifted 1, 2, and then 1, 2, 3. And this is going to be shifted over 2, and 1, 2, 3. And this one will look like this now. And I'm just not doing the other point. Okay, so this is what's going on here. And I thought, as I mentioned before, that this was an indication that we could, if you're in the, not the physical textbook, but the online textbook, if you click there, took a while for it to come up, but this is what comes up.
Now for these next 3 problems, we will be graphing translations of a given graph of f of x. A graph of a function defined by y equals f of x is shown in the figure. Use this graph to sketch g of x equals f of x plus 3. Now by adding 3 to f of x, the result is going to be a translation of g of x 3 units up. So what I'm going to do is take each one of these points and translate them 3 units up. 1, 2, 3.
Now, I watched this myself, and that's what I showed you as well. But again, this is your y-intercept originally here was 0, which is right there. So all of these are going to be just shifted up 3 places. Let's get a little bit further ahead here. I may not be able to do that here. Let's go here.
I'll take this one. 1, 2, 3. The original.
So what she's showing here, that if this is positive within the parentheses, it's not an up or down. This is a horizontal translation, a shifting. So there was our origin. We're going to shift it 3 units, opposite sign, to a -3. Okay, well, we're going to close this now. And I think this shows what we've just illustrated here. Okay, so here's a nice little summary. Again, some of you may want to copy this into your notes. This is going to be critical. And we've kept this tape, I guess, just to a little bit over 36 minutes. Very good.